Now, those who do know David won't be surprised to hear that he likes things to be correct and done properly. Rather than relying on gut instinct and feeling, he likes to have data and actual facts. And those who don't know David are going to find out. So David Bell, please go on.
Thank you. Hello everyone. Thank you for joining me today at Everything Open 2025 here in Tantanya, Adelaide. We're here at Tantanya, the place of the red kangaroo, on the country of the Kaurna people. The Kaurna people are the traditional owners and custodians of these lands. They've been hunting and fishing here, living and working here for more than 70,000 years. I would like to pay my respects to elders past, present and emerging, and acknowledge the continuing connection to the land, waters, sky and culture of Aboriginal and Torres Strait Islander peoples across Australia. Their sovereignty was never ceded. This always was, always will be, Aboriginal land. So, what happened in production and how can we use OpenTelemetry to solve it? We'll get to what happened in production in a minute. Who am I? My name is David Bell. I'm a dev-oop, so I mostly write YAML and yell at GitHub Actions for a living. But before the cloud and CI/CD, I was an ops person. So I'm working on turning my trauma into my profession by being an observability fanatic. I'm obsessed with building a shared understanding of what's happening inside the systems built and run by the teams I work with. That often means writing some pretty questionable code in languages I'm personally well out of my depth in understanding. We'll see some of my not so handy work a little later. I apologize in advance to the Python programmers in the room. And I have a spicy brain, and that means these sorts of systems and these kinds of approaches to problem solving really scratch an itch for me. And provide no shortage of opportunity to pull things apart. This afternoon, we're going to follow along the story of a mysterious, long-running incident. We'll talk about what is observability and the concept of knowns and unknowns. I'll subject you to my take on the apocryphal 3 pillars of observability. There's a chunk of theory crafting about OpenTelemetry, and then we'll bring that bit home with the fine print. I'll share a worked example of how we can instrument the system from today's incident. And with any luck, we'll resolve the incident, hopefully. So, the incident. This is a work of fiction. This isn't a presentation about anything, and I mean anything, at my current day job. I work at a bank. They're not so stupid to even think about suggesting talking hypothetically about a situation like this. I don't know of any systems that work like what I will describe, or incidents that have gone like this one at my current employer. This isn't the Don't Get Fired Challenge 2025. It will be entirely coincidental and highly unlikely I'd get nearly enough of the details right on recollection. So, we are, microliths are us. We're purveyors of fine, event-sourced, Internet of Things, microservice-backed architectures. And we've just finished a trial with our 59th client, our latest new big client. And I hope you don't mind that I'm on call for them today here. We should be fine. These systems are rock solid, as you can see. Our newbie client, Everything Open Attendees Incorporated. Yes, we've snagged a contract with Everything Open Attendees Incorporated. They've just finished a lengthy trial with a single device and loved it. So they're rolling it out to a selection of their fleet. How about I tell you about the system? So here's the TLDR. You, an Internet of Things device, are using an event sourcing model, so you ask us for the next chunk of events, newer than your current state by using an ID, and we gladly return them to you. You do this on repeat. Maybe there's not a lot going on, or maybe you're just a bit behind the times. Eventually, things stop happening, or you catch up and we send you back less, so you'll be back a little later. Oh, that looks a little odd.
Something's broken. It's your fault. It's your fault. Are you gonna fix it? Are you gonna fix it right away?
Yes, something is broken. Alert on events backend. Health check is failing. Yeah, you bet it is. What happened in production? Well, we can see the metrics on the screen and they don't look happy. And we can see a big old spike of errors there, and I don't know what's happened to the response time. That doesn't look good either. We can see something went wrong, but it doesn't really tell us much more than that, does it? But what about the logs? We have logs. How's my mouse? I'm over here. I mean, I guess it's all going well, and then, I guess it stopped going well. Nothing particularly useful there about what went wrong. I guess we just haven't hit whatever this is yet to have added any log message for it happening. Not really helpful. Microliths ROS went on like this for quite a while. 2 p.m. would roll around, events backend would strain under the load, sometimes recovering quickly, with barely an increase in latency and no one really noticing. Other times, totally locking the database, requiring a lengthy crash recovery. I myself spent many hours as an amateur database administrator, convinced more disk, memory, or CPU might save us. But we were trialing a new approach and a new tool, observability and OpenTelemetry. Microliths ROS had already added it to some platform team-owned systems to great success. But there hadn't been much movement in convincing product-owning teams. After all, their systems were clearly working quite happily in production. After all, people were paying for them, and our synthetic monitoring told us they were working. What's the problem? Sound like a familiar story? We'll return to that story after a little bit of theory. You know, the actual technical stuff you probably came here for. So, who or what is Ollie? Charity Majors, my personal idol in the observability space, introduced the term observability to our industry, often written as O11Y and pronounced Ollie in the style of Kubernetes being K8S or Kates. Charity paraphrased mechanical engineering and control theory to position observability as the ability to understand what is happening inside the system, any internal state, simply by asking questions. Some of you may already be familiar with this sort of table and the concept of known knowns and unknown unknowns, but forgive me for just a quick aside into this. So, knowledge is what we already know about our system. These are hard facts we individually or collectively know. Awareness is what our current or previous practices might be able to tell us about the state of our systems. We're aware of things we ask about, request volumes, average times, CPU usage, so on. We all have biases. It's important in any context to identify them, be aware of them, and challenge them. Ignorance feels harsh here. Opportunity feels corporate. Interesting stuff. Teach me something new. The observability industry is obsessed with the notion of observability having 3 pillars: metrics, logs, and traces. Conventional wisdom is you need all 3, and that if you get the balance of them just right, you'll reach DevOps enlightenment. So let's start with the first of the 3 pillars, metrics. Can you count on them? forgot to bring the drum set, obviously. Or maybe that should be metrics. But we all know them and are familiar with them. Minimums, averages, maximums, sums, maybe an exotic percentile or 99. Our cloud infrastructure loves to spit them out, and they know what they're doing, so that must be the way. Yes, but also no. They're pre-aggregated. That means they're bundled in increments and presented as an average or a percentile, and maybe have a very limited number of dimensions. Therefore, you can only they can only answer predefined questions that fit those aggregations and dimensions. They have no connective tissue between individual metric points. Each is just a single data point on a line. It can tell you something like the average latency over this 60 seconds was 500 milliseconds. But were some really fast and some really slow? Sure, a couple of minimum and maximum metrics will give you that. But you can't tie that together into any other metrics, such as error rates. You only know the ranges independently. You can't drill down on a metric. Yes, the load balancer returned 1,000 HTTP 500 errors, but which paths were associated with each? I mean, I guess we'll just have to check the logs to find out. But they aren't totally without use. We can answer questions we know about, such as how many errors were returned, or how quickly messages might be leaving a queue. We can draw some pretty graphs on slides or dashboards and make inferences about the shapes of the lines. We humans are great at picking out visual patterns. We can report on things like daily volumes, management like a good summary. And they're great for things we have knowledge or awareness of. But they fit and feed our bias and tell us nothing interesting. Tell us nothing about the interesting unknown unknowns. What about logs? We said we'd need to check those to see what endpoints were causing those 1,000 HTTP 500 errors. They're often either boilerplate logs from the framework we're building on in some bespoke format, or haphazardly spat out strings. Logger.info, starting request. Console.log, retrieved 1,000 rows, and so on. Some of us will have the misfortune of having learnt that text streams are the universal interface, so we'll be likely to be fortunate to be comfortable enough to break out sed to make sense of those logs. There are potentially many log lines for each piece of work or request. If you're lucky, they're tied together with a common identifier used in a common way across all log lines, like a request ID field prefixed on each log. My experience is that is highly unlikely, so you'll probably have to break out grep. Each of those log lines might have some useful data in them, or they might not. If it's there, you've got to tease it out by hand. Break out the entire GNU toolkit. Grep, sed, cut, pipe, sort, unique. Chuck some regex in there for good measure. If you have no schema or structure, it's hard to have an index to make searching efficient. I know I've personally previously downloaded system logs to parse locally rather than waiting on the logging platform du jour of previous employers, because the thing was just too slow, needing to extract the same fields again and again. Structured logging is fantastic if you can pull it off. What do I mean by that? As an example, I mean emitting all of your logs as JSON with clear and consistent key value pairs for all of your fields. But all that logging data is expensive, especially for you to process and store the field names on every single one as well. I'm sure anyone who's worked somewhere with one of the large incumbent logging platforms knows the pain of either administering that platform or having the administrator coming to tell you to stop logging so much. Log everything, find nothing. Die unfulfilled. Some of these are taken from stickers that Charity makes that I think are fantastic, so credit to her. but we should still log. They too have a place, namely, for my opinion, audit logging and security events. Stuff you need to get written down in a way that blocks the execution of your program if you can't record the log. When it comes to containerized applications, it's common to output logs on standard out. If you can't output on std out, something is probably very, very wrong, and then you shouldn't or even can't process the request. If you can't log the sign-in request, the sign-in request shouldn't happen. 2 pillars down, 1 to go. Tracing. Tracing must be the one true pillar then. No? Maybe, but historically, not really. It's often kept in a separate tool, away from where you're used to seeing your metrics on fixed dashboards and your logs in your expensive, either contractually or operationally, logging tool. So you might get an alarm from a metric, such as an error rate or response latency, which gives you a rough timestamp, plus or minus a minute. Then you go look at your logs, which might have some idea of the methods and endpoints involved and a more accurate idea of the time of the problematic request. If you're lucky, you'll have tracing tools of some sort and might even have a trace from one of these requests. Does it have the business context that's relevant to you? Has it been molded to your use case, or does it just tell you what you likely already know, that you mostly wait on the database to return responses? And if it does have those things, my personal past experience has been that it's then typically tuned to only look at bad events. Errors, latency, that sort of thing. But how can you know what's making it a bad trace if you have no baseline data available from the same time of what might be a good trace? And given it's historically been mostly used to look at bad requests and the purpose of a system is what it does, that's all tracing systems often want to show you. The bad traces. Here are all of your errors. What does it look like when it's working? There's limited capability to use the data in other ways, such as searching across it. Apologies to those of you I may have now earwormed with Frozen 2, but we're here to dig into the interesting stuff going on inside our system. To be able to understand the internal state from outside just by asking questions. So let's take a look at OpenTelemetry. OpenTelemetry, often shortened to OTel, is a project and open standard maintained by the Cloud Native Computing Foundation, the CNCF, the same folks who oversee Kubernetes. This project will fit so many pillars you wouldn't believe. It's got you covered on metrics, logs, and traces. It has a wide range of languages supported, including Python, Java, JavaScript, Node, and Web, Golang, and Rust, to name some of them. And while I can't speak for all of the supported languages myself, the ones I've used, I definitely consider them batteries included with auto-instrumentation. Auto-instrumentation is applied differently depending on the language, but think of it like a set of wrappers or hooks into the commonly used libraries and SDKs that provide context about what your application is doing without you writing a single line of code to get it. An example of what that looks like is knowing effectively for free how much time you're spending waiting on a database call without needing to handle the timers yourself or tease out the which database connection, user, table, normalized query, and so on were used. They're all added for free to the automatically created span as attributes. I'm off by one on that. There we go. It's also, no, I wasn't. Maybe I was. I don't know. It's also super simple to get started, and you can often enable it without modifying a single line of application code, just by calling your app via a wrapper or providing an agent. I've previously rolled out auto-instrumentation to an entire fleet of Java microservices by adding it to the in-house Docker base image. It was incredible the scaffolding that put in place to then be able to go and add manual instrumentation, building on top of the context that was created on the incoming and outgoing request spans in each of those systems. We were then able to add our own business context to those. Which those auto-instrumentations also handle propagation of trace context between distributed systems, meaning you can share the same trace across multiple systems written in multiple different languages. Distributed tracing is commonly handled by request headers passing along the identifiers for the trace. The auto-instrumentations know how to both serialize and deserialize these values and how to inject them and retrieve them back out of the incoming and the outgoing requests for you. There are heaps of vendors that support it as well, and various tools that you can run yourself and all sorts of things. So you can try sending data to multiple to find the right fit for you and your team. I'm personally using Honeycomb today, but if they stop keeping pace or a better player comes along, I've been talking to Josh about Grafana this morning, well, sorry Erwin. OTel tracing's where it's at, but what is it and how does it work? Traces are DAGs, directed acyclic graphs. That is, each node can only point to a single other parent node without any loops. At the top, we've got a node with no pointer elsewhere. We commonly refer to that as the root span. The nodes in the DAG are spans. A span represents a chunk of work, a literal span of time. You can think of spans as a fancy structured log, a big old pile of JSON with some required fields. A name, a start and end time, the span's context, its trace ID, the parent span ID if it has one, and its own ID. Typically that's all handled by the OTel SDK for you, but you can dive in and do it by hand if you need to or want to for some reason. Those fields are referred to as attributes, and your spans can have many attributes. Some are provided by the auto-instrumentation, some you can provide yourself based on your application's specific business context, domain context. We have both high cardinality and high dimensionality. Cardinality refers to how many values can be assigned to or tracked by a single field. A high cardinality field might be conference ticket number, or invoice number, or seat number, or height. A low cardinality field might be attendee species. Did anyone's cat buy a ticket? There were online-only tickets available. Dimensionality cuts the other way, and is how many attributes a single span might have. The wider you go, the more enriched these spans, the easier it'll be to uncover the unknown unknowns. We can have high dimensionality, meaning we can have almost as many attributes or fields as we like. There can be a limit. It's up to the platform you're sending to. Honeycomb, for example, accepts no more than 2,000 distinct fields on a single event.
I'm sorry, Dana.
But all things in moderation. OTel tracing won't solve all your problems. Just as with your logs, you shouldn't stick your PII in your tracing. That should really go without saying, and yet I also don't think it's a replacement for business analytics engines or your data lake or anything like that, but that's also not really personally my bag. That's just been my experience so far, so maybe there's something in there, I don't know. There's no guarantee on delivery. This is a tool designed to help you when your system is failing. You don't want to discover that it was the cause of the failure. So it gets itself out of the way when resources are contentious. The trade-off here is between system health, but the occasional mistrace, or total outages, but aggressively trying to track everything. That means that it's also no good for audit and security logs that we talked about. OTel is non-blocking, typically, or by default. But as I mentioned, audit logging probably should be blocking. But we can lean into the lack of guarantee and build on the fact that we might not get a trace for every single request, and use sampling to manage our data volumes. We don't need every trace, sampling will do. Just like getting a blood test, your GP doesn't need to drain your body to tell you your iron level just a little goes a long way. There's two approaches we can take, heads or tails. Head-based sampling is deterministic based on the trace ID generated before we do any work. We can configure what proportion of IDs should be included in our sample, and that decision, based on the trace ID, is propagated throughout our system. Tail-based sampling is non-deterministic upfront. We don't know which traces or spans we will or won't keep until we look at what's available after they're generated, after the work is done, and make a judgment. Maybe we'll keep 1 in 50 traces for fast, successful requests, but 100% of anything slower than, say, 3 seconds, or that has an error somewhere in it. When you're starting out your OpenTelemetry journey, I recommend keeping it simple and using head-based sampling until you get a handle on your span volumes. And you can always tune the sample rate back up, either for an individual system or your environment if you have an incident that you think requires greater fidelity of that data. Yeah, that's fair. So, what's going on over at microservice RS? Can we get some of that sweet, sweet observability for events backend and find out why the service fell over? We're going to take a quick look at the instrumentation done for events backend, starting with auto instrumentation. We'll need 2 packages. That's it. OpenTelemetry distro and OpenTelemetry exporter OTLP. Distro installs the API SDK and a couple of tools, including OpenTelemetry Bootstrap. The exporter is required for being able to send our spans somewhere using OTLP, which is the OpenTelemetry protocol. Bootstrap will check your app and collect the various other OpenTelemetry auto instrumentation packages you can use based on what your app is already doing. You can use it with your existing requirements.txt or have it just go and install those packages standalone. Here's the list of packages it installed in this particular app where it's providing auto instrumentation for us. You can see Flask, MySQL client, requests, SQL Alchemy. So that's good that we'll get auto instrumentation leveraged for those things. But there's also a few we don't really need, and I probably should have removed them. Ginger2, SQLite, WSGI. I suspect they're coming along by default with either Flask or SQL Alchemy, but no. And here's the required config. Service name, the protocol you want to output with, where you want to send it to, and potentially any authentication headers that might be required. It's no secret, I like Honeycomb, and so this is what my config looks like for this service right now, without my API key. I almost wish there was more to it than that, but that's genuinely it. And then to run it, you either use the OpenTelemetry instrument command to wrap your call, or it works great in a Docker file too. Modifying your entry point script is a great way to quickly roll this out if you're already using your own internal Docker base images. I mean, okay, but it's very, very little more than that. So that was the zero code auto instrumentation, but you're right. Let's get all this out of the way now, and then we'll look at the data and identify the trigger point of our incident. Here's how you might add manual instrumentation to your app if it were written in Python and using Flask and written terribly by me. Up the top, we've got a couple of imports. Then we require a tracer. You can call the tracer whatever you want. If you're putting it in an internal app or a library or some package that you're making open source, it's probably best to use that app or library's name though. It's a helpful pointer to be like, this code came from here. Let's get rid of that top bit so we can see the rest of the code clearer. So we've got a span created by auto instrumentation because we've got that app route decorated there from Flask. But we have to ask for the span if we want to be able to handle it ourselves within this function. Alternatively, you could create a new span, but it's not necessary unless you specifically wanted to break the execution here out from the auto instrumentation span that already exists anyway. We can then add some attributes to the span as we go. You don't need to worry about string building or anything like that, which might otherwise need to be solved as if you were doing structured logging on your own. Just throwing the values into a dictionary and passing that into the attributes of the span will do. I like to collect the attributes as the function progresses so that we can have the most complete picture of the state of the inside of our system from outside if an exception gets thrown at some point. Speaking of exceptions, look Ma, I wrote me some Pythonic code and sought forgiveness and caught my exceptions. If something goes wrong, this will add that into the span, it'll mark the span as having an error, and create a span event at the exact time the exception was handled by this code. That's everything. No more tricks up my sleeve. Sorry, one last trick up my sleeve. The Python decorator. Cute, huh? Whenever you call this function, a span will be created at its call and ended at its return. You can expand on this as with the previous auto-instrumented function, adding attributes or recording an exception. But it's great for wrapping loops that you might wonder how long they take. Or if there's, something interesting that you want to try and understand better, or particularly complex business logic functions that you need to get some transient attributes out of. I've kept you waiting as long as I can. So, what happened in prod? This is going to be mildly awkward to do from here, but see how we go. So this is Honeycomb, where all the data has been sent from before when the system crashed. Oh no. We're going to first just take a look at what the raw data looks like as presented in here. So I'm just going to pick a single trace and we'll filter down to that and go from there. And with this one. So here is all of the spans that were associated with this one trace, this one particular request. So you can see this one here is our root span. It has a trace ID, a span ID, but no parent ID. All of the other spans within this have a parent ID that refers to one of the other spans listed in this table. We can also see all of the fields listed here, all of the attributes that exist on each span within this table. You can format this different ways if you wanted to, or depending on your tool, it might just be things that you're querying directly out of. So we can also take a look at a trace waterfall of this. So this represents the time taken by each span, as well as that parent-child relationship of each. It's a pretty flat structure, I guess, in this case. But we can see that, as expected, we spend the most time in the database waiting on these selects. We can also see from this example that we're getting double ups of both the sets and the selects. Why is that, you might wonder? It's because we have both the SQL Alchemy auto instrumentation and the MySQL client instrumentation. So they're both doing the same thing. You'd probably pick which one you liked better or which one you needed better and just get rid of the other one, and that would cut down your span volumes by 2 per request at least. All right, so let's have a look at what happened earlier. We'll go back and we'll have a look where things fell over. What we're probably interested in is the time taken. I'll do that in a minute actually. And we're only going to look at the root spans because let's just look at that outer layer, because we know that the auto instrumentation treats the incoming request as the root of our traces, and we know that a bunch of them went quite badly. And we're going to group by those HTTP status codes. All right, here's where things went wrong, I think. So this first graph here is grouping. This line is 200 responses. This line is 500 responses. We've got some 201s coming in as well, which is the events being added to the table. Right, that's the put requests ingesting events. And then this is a heat map of our duration values across the time axis, or the y-axis is showing the individual values recorded. So up to 100 seconds was taken. Typically, it's somewhere down below 2 seconds. The shading of each box on this graph shows how many events fell into that particular bucket at that particular point in time. So, look, there's probably the problem. I'm not going to do it that way yet, though. We're going to look at, we're going to compare all of the attributes of where there was a 500 response versus either a 200 or a 201. And this will show us all of those attributes. So we've got 35 different attributes available here, plus some measures, which are basically just numeric ones. We can see, for example, it pretty much impacted every customer. There's a couple of customers that looked like they either missed out or got entirely wrecked by this. Yeah, can't really tell much there other than that it affected everyone. Everyone missed out. But if we zoom in a little bit closer to the event, we should be able to see that some of these early responses that were getting errors, if we pick on just these ones, if this worked as it did before, which of course, really asking a lot for the demo gods here. Nope. Amazing. Great. Let's look back a little bit further when it worked before the talk. Oh no, this is a terrible system. It falls over a lot. Let's look at yesterday's incident. All right, this one looks better. Excellent. Good. These ones started failing before everyone else started failing. What happened with those? Because they're probably the ones that were the leading cause. If we scroll down here, interesting. It was only where the offset, so that starting ID of the event sourcing was, where'd the mouse ever go? 0, versus everyone else's who's a lot. It was only customer number 60. And just to confirm things, let's pick a trace from one of these slow first ones. Yep, we waited for the database for a minute. That's probably a while for a select to take. We can have a look. Here's the query normalized here. We happen to know what these values are because we've added manual instrumentation up here. So we know that it's customer 60, that they wanted 1,000 events and they were starting at 0. For comparison's sake, let's pick one of these back when it was happy. And it'll be the same query, same super contribution, different outcomes. No, customer ID 2, and they only got 52 events returned, and they asked for 1,000. So they're pretty up to date. Where'd my mouse go? Here we go. So there's something about customer ID 60 and starting with such a low offset. But wait, wasn't our new customer number 59? Yeah, but we needed a fake customer for our synthetic monitoring. Turns out they don't have much traffic. Just the one row. I bet that's a quick query and not particularly representative of our real customers. So let's look at our largest customer compared to our newest. Well, that's a disparity in volume of data and where the data sits in the table. Yes, there are many ways that you would slice this if you were doing this for real, right? You would shard your users or do something else smart with the backend. Microservice is a startup. We haven't had a new customer in a while. Well, there's your problem. I don't know much about databases, but I bet you typically want to avoid a table scan. I bet these queries take forever to return. given the chance. It took a lot to convince the query planner to do this, so I was really happy when it started happening. I pushed a new version of the app using what we've just learned about how new customers using new devices aren't able to get off the ground with events backend. And we can see from the metrics, it's doing a little better now. The response times are up, but no errors yet. This is a really contrived example. I had to cap the query timeout and the number of connections to the database to cause this to be a problem, but left uncapped, this sort of thing has the potential to crash your database instance if your compute will have to scale up while this went on. And we didn't have that sort of time to wait around for it to potentially fall over. So I hope you enjoyed this look into observability and OpenTelemetry, and that you'll be able to give it a go in some of your trickier systems. Thank you.
Thank you, David. Do we have any questions?
So, as I understand it, Honeycomb is a sort of a software as a service type product.
Yes.
Is there something I can sort of self-host, or do you
Turn
have
around
any
and talk to the man behind you who works at Grafana. I'm sure he'll be happy to point you at some documentation.
You might recognise the face.
If you also check out the OpenTelemetry website, they've got some really terrific documentation on there, as well as like an ecosystem where you can search for the libraries you can use, the things that you can run yourself that you can send it to, the things you can pay someone else to worry about that problem, all of that. Yeah.
Anyone else? No? Oh. Hamish got him first.
The graphs on your slides, are they actually live?
They're actually live.
What have you done to build that?
Sorry?
What did you use to build that?
Grafana.
in the slides?
The slides is Reveal.js. Like I said, I write a lot of really hacky things sometimes, and it was a great distraction from writing the actual content of the talk to build this bit first and work backwards from there. It's their iframe embedded panels out of Grafana dashboards, and then I hacked the CSS to make the background disappear so they wouldn't look like Grafana. Sorry.
Thanks, David. Great talk. Where do you see observability and machine learning and AI going?
I'm not sure. I'm not a big user of those sorts of tools personally. Like I didn't use Copilot to write the demo thing. Maybe I should have, and that would have been easier. I think that my personal opinion is that it requires like a human brain to actually understand it instead of a computer brain to give you an understanding-shaped response. A thing that looks like it understood, but actually doesn't know how many R's are in strawberry. How many errors are in my system? 3. Who knows?
One last one.
Looks like this OpenTelemetry is really good for looking at inside your application. But how do you extend that to everything else that's going on to the system, which is also affecting your system? I mean, operating system.
Yeah.
Other things happening in the operating system.
I mean, there are, as part of that ecosystem that I mentioned that OpenTelemetry have, there are ways to hook into things like databases or load balancers and turn the data that's available in those systems into traces as well, and data that OpenTelemetry systems can actually work with. A really fun example that I like is putting GitHub Actions or any CI/CD platform. What's an execution of a CI/CD platform but a trace? It's just a DAG. Everything takes an amount of time and has dependent relationships and things like that. So turning that into tracing is really fun to be able to say, that PR merging suddenly started failing our tests 10% more. And being able to go and tap that dev on the shoulder and go, I'm reverting this for you. Ha ha. Yeah, good fun.
Just one last one. You're going to be around all the event, aren't you?
Yeah, of course.
This is a comment more than a question. You needed to have one of those. No, this is, I'm Erwin, I'm from Honeycomb. We're super excited to be sponsoring the conference as well. And so one of the things is I'll be doing a quick sort of Q&A around sort of Honeycomb with some OpenTelemetry. So if you're interested, I'll be doing that sort of during the break here.
Okay, awesome. All right, well, David, thank you so much for that. And we've got a wee gift here from you that has been designed and made by one of our own volunteers here in Adelaide.
Wow,
So
cool.
display that proudly as one of our speakers.
Thank you.
Well done, thank you.
Thanks so much.